Good morning, dear student. In today's lecture, we will discuss the next topic or chapter, that is the epoxidation reaction. The epoxidation reaction of alkenes. So, in previous lecture, we will discuss the metal catalyzed oxidation reaction. So, in this lecture, we are very much interested in the epoxidation reaction of alkenes. So, for epoxidation reaction, we select the alkenes such as propylene. So propylene CH3 CH double bond CH2. So epoxidation of this propylene by using molybdenum as a catalyst, molybdenum complex as a catalyst in presence of tertiary butyl hydroperoxide. Tertiary butyl hydroperoxide to gives the epoxide plus tertiary butanol. So the general reaction is what? Alkenes react with tertiary butyl hydroperoxide in presence of molybdenum complex as a catalyst, and it will convert its oxide, that is it will convert into epoxide with elimination of tertiary butanol. So let us discuss the mechanism for this epoxidation reaction. So the pre-catalyst for this epoxidation reaction is the molybdenum hexacarbonyl complex, that is MoCO6, molybdenum CO6 complex. So if you consider its coordination number is 6 and molybdenum it is in zero oxidation state. So these carbonyls are neutral ligands, so it is in zero oxidation state. In presence of strong oxidizing condition, in presence of strong oxidizing medium, the MoCO6, that is the pre-catalyst, is get oxidized into a species which is denoted by 8.21. It is denoted by 8.21, that is in which after oxidation the MoCO6 get converted into molybdenum which is attached to 2 oxygen, 1 hydroxyl group, 2 solvent molecule, and in absence of solvent molecule the vacant site it is occupied by tertiary butanol, that is O having plus sign, so it is tertiary butanol. So this MoCO6 under strong acidic condition it is converted into 8.21 species in which the molybdenum is in plus 6 oxidation state. Molybdenum is in plus 6 oxidation state. So these 2 oxygen, double bonded oxygen having minus 2 charge, and this hydroxyl group and this tertiary butanol oxygen having minus 1 charge, and therefore the overall oxidation state of this molybdenum is plus 6. So in the first step, that is the species 8.21 react with your tertiary butyl hydroperoxide, that is tertiary butyl hydroperoxide, the plus sign and 2 oxygen 1 hydrogen, that is your tertiary butyl hydroperoxide. So when the reaction with tertiary butyl hydroperoxide, it eliminate tertiary butanol and one solvent molecule and forms a chelated tertiary butyl and form a complex in which there is a chelated tertiary butyl hydroperoxide as a ligand. So the species 8.21 react with your tertiary butyl hydroperoxide, so it will eliminate tertiary butanol and one solvent molecule to forms a chelated species in which both the oxygen, that is distill oxygen, and the oxygen which is attached to tertiary butyl group are attached to the metal atom, and the species, that is 8.22, is formed after the reaction with a tertiary butyl hydroperoxide. So one solvent molecule and one tertiary butanol, it is replaced by this chelated tertiary butyl hydroperoxide. So from this species, that is tertiary butyl, the chelated species which is formed after addition of after reaction with tertiary butyl hydroperoxide. So there is a two route to get your final product, that is we get the epoxide, that is path first and path second. So if you consider the path first for this catalytic cycle, in path first the 8.22 species react with your alkenes, that is propylene, carbon-carbon double bond species. And if you consider the mechanism, it will react with your alkenes and the formation of species, that is 8.23, in which the propylene undergoes electrophilic attack by the distilled oxygen atom. So the reaction, that is 8.22, it will react with your alkenes, carbon-carbon double bond, and there is an electrophilic attack. There is an electrophilic attack by the distilled oxygen atom, on this carbon-carbon double bond. So what is this distilled oxygen? The oxygen which is away from the tertiary butyl group, the oxygen which is away from the tertiary butyl group, it is considered as a distilled oxygen. So this distilled oxygen, it will attack on electrophilic center. So if you consider the bond between molybdenum and oxygen is break, so you can see that the propylene undergo electrophilic attack by the distilled oxygen atom, and at the same time electron rich carbon, it is attack on oxygen, and the bond between oxygen and tertiary butyl group is break, and we get a species in which the molybdenum, it is attached to only one oxygen. The molybdenum which is attached to only one oxygen, that is we get a species that is 8.24. So after reaction with carbon-carbon double bond, and if you see the bond between the new bond is formed between the molybdenum and the new bond is formed between this carbon and oxygen, and the bond between oxygen get break, that is the bond between molybdenum and oxygen is break, and oxygen, it will forms bond with two carbon atom, that is the carbon atom of alkenes, and finally we get other species, that is 8.24. so we get 8.24. so it is very simple. The first step is what? The reaction with tertiary butyl hydroperoxide, it will replace tertiary butanol and one solvent molecule to form the chelated complex, that is 8.22, that is in which the tertiary butyl hydroperoxide is a chelating ligand, and then it will react with alkenes, that is path first, 8.22 species react with alkene, so electrophilic attack by distilled oxygen on this alkene to form the species, that is 8.24, in which the molybdenum oxygen if you consider the oxygen bond is break, and if you consider the new bond is formed between the two carbon atom and oxygen, and we get the species, that is 8.24. after that it is very simple, that is the replacement of this epoxide which is formed, which is a ligand attached to this molybdenum, it is replaced by the solvent molecule. So the last step is very simple, the replacement of this epoxide ligand by the solvent molecule, and again we get the product that is we want, that is we get the epoxide, and again we get the active catalyst, that is MO, which is attached to 2 oxygen, 1 hydroxyl group, 2 solvent molecules, and 1 tertiary butanol. So this is the path A. If you consider path B, so what is the difference between path A and path B? So in this case, in path B, there is a direct coordination of this alkene propylene with this molybdenum complex, that is a replacement of one solid molecule by this carbon-carbon double bond. So this is path B. If you consider the 8.22, it will react with your alkenes, and there is a direct coordination of this alkene with metal atom and the replacement of one solid molecule. Again, if you consider then there is a again insertion reaction. If you consider, then there is an insertion reaction. So if you consider this reaction, this molybdenum, it is attack, it will forms. If you consider, there is a rearrangement, that is, we know that one of the carbon is attack on this oxygen. At the same time, the bond between, we can say that the molybdenum oxygen bond is break. So when this oxygen, it will forms the bond with this carbon, the hapticity 2 is converted into hapticity 1. So what is going on in this reaction? That is 8.22 species react with alkene, that is carbon-carbon double bond, to form a coordinated species by the removal of solid molecule. In the next step, we get a 5-membered species, 5-membered chelating ligands, because one of the oxygen, it will forms the bond with carbon atom. At the same time, when it will forms the bond with carbon atom, the bond between molybdenum and oxygen get break, and at the same time, when the oxygen binds with this carbon, the hapticity 2 is converted into hapticity 1, means the only one carbon, it is attached to the metal atom. If you see the species, that is 8.26. So if you consider, it is molybdenum attached to 2 oxygen, 1 OH, and from one side there is oxygen, and from other side there is a carbon. So it is a cyclic ligand. So if you consider the coordination number, 2 oxygen, 1 OH, 3, then 1 oxygen, 4, and 1 carbon, 5. So one vacant side, it is replaced by the solid molecule. So in between the ring, it is S. So the solid molecule occupy the vacant side, that is 6th. So we get 8.26. So how will we get 8.26? So the oxygen, it will forms the bond with carbon, and the hapticity 2 is converted into hapticity 1. So only one carbon is attached to this molybdenum. The species 8.26 undergo a rearrangement, undergo modification, and finally it is again converted into the species, that is 8.24. So we know that after formation of 8.24, it is very simple to convert the 8.24 into the product, and the active catalyst, that is 8.21. So just a replacement of this epoxide by the solvent molecule, and we get the final product, that is the epoxidation of this propylene, and we get the active catalyst, that is 8.21. So this is a very simple mechanism for this oxidation of propylene based on molybdenum complex catalyst. So you should remember the general reaction, that is the conversion of propylene CH3 CH double bond CH2 in presence of tertiary butyl hydroperoxide and molybdenum complex as a catalyst to give epoxide plus tertiary butanol. And all these steps are very simple. So you should remember the pre-catalyst is MoCO6, which is on oxidation with strong acidic medium convert into the species 8.21, which is on reaction with tertiary butyl hydroperoxide convert into 8.22, which is in which the hydroperoxide, it is act as a chelating ligand. Then it will there is a two path A, path B. So path A, in path A, the electrophilic attack by the distal oxygen on this carbon-carbon double bond to use the 8.24, and this 8.24 again react with solvent molecule to give the product and the active species. Similarly, the path B, so there is a direct coordination of alkenes with this 8.22 with replacement of solvent molecule, and then the oxygen forms the bond with one carbon, and the hapticity is 2 is decreases by 1 unit, so only one carbon is attached to molybdenum. We get the cyclic ring, that is 8.26 species, which is undergo a certain rearrangement, and it is finally converted into 8.24. Again, the 8.24, the replacement of this epoxide by the solvent molecule, we get your final product and the active species. So this is all about the epoxidation reaction of propylene in presence of molybdenum complex as a catalyst. Thank you.